Hi there, and welcome to Physics 101. Today we will be teaching you about Newton's three laws of motion: inertia, force equals mass times acceleration, and equal and opposite reactions. Let's begin with inertia, the first law of motion. The first law of motion states that an object in motion will stay in motion, and an object at rest will stay at rest unless acted upon by an unbalanced force. Inertia is the explanation for why people can be ejected from cars in car crashes, why hot coffee can spill when you slam on your brakes, and why this ball will not move unless thrown by an outside force. Basically, an object at rest will remain at rest unless acted upon by an unbalanced force, and an object in motion will stay in motion unless acted upon by an unbalanced force. Newton's second law of motion is force equals mass times acceleration. Have you ever tried pulling a really massive guy in a sleigh before? It's pretty tough because more force is required to move him. Hey Santa, lay off those cookies. Let's break down the equation. Say you have a car weighing 2,000 kilograms and you want it to accelerate at 5 meters per second squared. You plug it into the equation and the force comes out to be 10,000 newtons. Now a massive truck weighing 15,000 kilograms with the same force of 10,000 newtons will only accelerate at 0.67 meters per second. Based on the equation, we know that larger objects take more force to accelerate them because they have more mass.
Oh my gosh!
Finally, we're on to Newton's third law of motion, which states, for every action, there is an equal and opposite reaction. Let's say we have Joe Cool over here leaning against the wall. The reason he does not fall through the wall is there's an equal reaction to his force against the wall. The force exerted from the wall balances the force of the push, so the net force comes to zero. The same goes for gravity and the normal force from the ground. This has been a Varsity Physics production on Newton's three laws of motion.